The 1960s and 70s. These were the years when the space race dominated the skies and nuclear competition dominated the ground. In the Soviet Union, engineering and technology were the most crucial tools for national pride and ideological superiority. When the United States conducted high-speed rail experiments using jet engines during this period, it mobilized decision-makers in Moscow. The goal was not just to surpass a rival, but to usher in the age of speed in passenger transport without having to completely replace the existing railway network. The result of this ambitious goal was one of the most extraordinary railway projects in history, the Skorostnoye Vagon Laboratoria, or simply the SVL, the Soviet jet train. The engineers at the Kalinin railcar plant who undertook the development of the project proposed a radical solution for high-speed travel. For the experimental vehicle, a widely used ER-22 type electric commuter carriage was selected. However, what was mounted on top of this ordinary carriage transformed it into a legendary monster. Two AI-25 turbofan jet engines from the reliable Yakovlev Yak-40 regional aircraft were installed on the roof of the carriage. These engines were positioned at a special angle to provide thrust. The theory was that these engines would push the carriage through the air, overcoming the rolling resistance of the wheels and the drag of conventional rail systems. This laboratory carriage, weighing approximately 50 tons, was fitted with a rounded, fluid nose section resembling an aircraft to minimize aerodynamic drag. Inside the carriage, a variety of sophisticated recording instruments, sensors, and test equipment were installed to monitor and control the speed trials. This machine was quite literally a mobile scientific laboratory designed to test the future of rail transport, an aircraft resting on rails. When the SVL was brought to the test tracks in the early 1970s, it delivered more than the expected performance. As the engines were fired up to full power, the carriage practically soared over the rails. The peak speed achieved during trials exceeded 250 kilometers per hour. This figure was an unbelievable success for the Soviet railway infrastructure of that era. The engineers believed this speed could be significantly surpassed if the vehicle were used on modern tracks and equipped with even more powerful engines. The successful trials of the project marked a moment of triumph, proving to the world that the Soviet Union could be a technological pioneer not only in space but also in land transportation. However, technical success unfortunately did not translate into practical viability. The project quickly succumbed to two fundamental foes: economics and physical safety. First, the fuel consumption was unacceptably high. Jet engines were designed to fly an aircraft at high altitudes. Operating them at low altitudes and on a rail system made them incredibly inefficient, pushing operational costs to astronomical levels. Second, the safety and infrastructure problems were even more devastating. The enormous thrust generated by the engines not only propelled the carriage forward, but also scattered the ballast gravel on the trackbed at bullet-like speeds. This posed a severe risk to surrounding structures, nearby equipment, and passenger safety. Furthermore, the existing aging Soviet rail lines were simply not capable of withstanding the constant vibration and stress caused by a vehicle traveling at such high speeds. All these practical and economic obstacles led to the project being halted in the mid-1970s. Despite its potential, the SVL was never commissioned for passenger service. It remained a testbed. This mad machine, which promised the transport of the future, was pushed aside and left to rust in a rail depot for years. Today, this jet train is seen as a concrete symbol of the characteristic boldness of Soviet engineering from that era and the quest to solve everything with a jet engine. The Skorostnoye Vagon Laboratoria is not just a transportation experiment, it is also a striking reminder of how high-tech dreams often clash with the economic and physical realities of the real world.